Alright, today we're going to be looking at dienes. In our previous video, we've looked at alkenes. Now let's look at dienes. Di means two. In is talking about alkenes. Now alkenes are hydrocarbons with two double bonds. So take for example, if you have something like this. If you check, this is single bonds throughout. If you have this is just your normal alkene. Now, if you have two double bonds located anywhere within the chain, makes that hydrocarbon a diene. So here we have a double bond, here we have another double bond. So this is a diene. Good. So diene is hydrocarbon with two double bonds. Now, we have three main classes of dienes, and the three main classes of dienes are cumulated dienes, conjugated dienes, and isolated dienes. All right, let's look at the cumulated dienes. In cumulated dienes, the double bonds are located on the same carbon. The two double bonds are located on the same carbon. What does that mean? If you have this example here, if you have something like this, check very well. Now, if you notice, you see that this carbon 3 here, this carbon 2, this carbon at the middle here, this double bond is on this carbon, this other double bond is still on that same carbon. Now, in this case, we call this cumulated diene. This is a cumulated diene. And if you are to name this, first of all, know the parent. This is 1, 2, 3, 3 carbon. So you know it should start from pro something. Please, if you miss any video in this series, go back to my channel and watch any of the videos you missed. Now, 1, 2, 3, so pro. So it's starting from pro, pan. We are having the diene on carbon 1 and 2. So propan, 1, 2, diene. That's how to name it. Though I'm going to take a section for naming, like a section for naming directly. Now, this particular case, you can just name it propan diene because there's no way you can place any other double bond. There's no way you can place double bond in this 3 carbon hydrocarbon without placing it on carbon 1 and carbon 2. And whereas you go on, you understand what I mean. The next one is conjugated diene. Now, conjugate double bonds. In conjugated diene, what happens is, let's take this example. If you look at this, if I place one double bond here, I give one space. Place another double bond. This is how conjugated dienes look like. So, for conjugated dienes, you have a single bond separating the double bonds. Now, a single bond separating the double bonds, that's conjugated bond. So anytime you want to identify, is this cumulated? Cumulated, they are together, no space. Conjugated, one double bond, one space, one double bond. All right. The next one is isolated diene. Isolated dienes, the double bonds are separated with 2 or more single bonds. What does that mean? If you have something like this, if you have something like 1, 2, 3, 4, 5, a double bond is here, a double bond is here. In this case, what you're having here, if you observe very well, this is a double bond here. One single bond, another single bond, then a double bond. In this case, we said these are isolated dienes. They are isolated from each other. Do we understand? If they are together, cumulated, one single bond and another double bond, conjugated. Then if they are separated by 2 or more single bonds, we said they are isolated dienes. Now basically these are the 3 classes of dienes. But the most stable among all, the most stable is conjugated diene next to isolated, and the least stable is cumulated diene. Alright, the next thing we're going to look at is how to name dienes, because it's very, very important. How do we name dienes? That's the next thing. Alright, now let's look at how we can name these compounds. Let's look at the first one. I'll do the first one I'll do the second one, I'll do the third one, and you have a classwork to do for me and drop your answer in the comment section. All right. But it's very, very simple. Now, if you're asked to name this compound, the first thing you are to note, the first thing you are to do is to number it, to know where the double bonds fall. First, how many carbon do we have here? We have 1, 2, 3, 4, 5, 6. 6, and it is a straight chain. All right. Now, I'm to number it in such a way that the double bonds will have the lowest possible numbering. So if I number it from left to right, I'll have here 1, 2, 3, 4, 5, 6. If I number it this way, the double bond is on carbon 2 and carbon 4. So 2 and 4. If I number it from right to left, I'll be having 1, 2, 3, 4, 5, 6. The double bonds will be on 2 and 4 also. So in this case, anyhow you number it, the double bonds are still on carbons 2 and 4. So anyhow you number it, you still be correct. Now, we've noted the position of the double bonds as 2 and 4. The next thing you ought to do is, you already know it's 6 carbon, that is hexa. Is it not? 6, is it not hex? 6 is hex, right? So the next thing is hex. Hex. Are you saying it? Hex. You put hyphen. We already know since there are 2 double bonds, it's a diene. Now hex. You put the position of the double bond first before you put diene. So 2, 4, so hex. 2, 4, diene. Simple. Hex 2, 4, diene. That is it. But let me ask, what class of diene is this? Is it cumulated, conjugated, or isolated? Double bond, single bond, double bond. So this obviously is conjugated double bond. All right. Now the next one, this second one, you have to put your eyes down, because some persons here, are you seeing brackets here? Some persons at this point they will give up. Now, anytime you see something like this written in brackets, this thing is same thing as writing it like this. Look at it very well. This bracket then I put CH3 means bring it out. It's a substituent. It's not part of the chain. Are you seeing it? So I just brought this one, put it on this carbon. Bah, then I continue. Are you seeing it? So this whole stuff is the same thing as this. So anytime you see a bracketed substituent, just bring it out. This is it. This is how it's supposed to be. Now with this we can name it. We have to number the chain now. Numbering the chain, we can go 1, 2, 3, 4. Right? So you can see that the double bonds are on carbon 1 and carbon 3. Carbon 1 and carbon 3. Please, you don't take this one and say the double bond is on carbon 4. You take the first one, you mix the double bond. So carbon 1 and carbon 4. But we have a substituent that we did not count here. This one. So we have to name the substituent first. So the substituent is on carbon 2. So we'll be having 2-methyl. Then the parent is how many? 1, 2, 3, 4. So 4 should be buta something. 2-methyl butan. The double bonds are on 1 and 4. 1 and 3. So butan 1, 3 diene. You can also say buta 1, 3 diene or but 1, 3 diene. So let me go with that. But 1, 3 diene. You're very correct. All right. So that's that. Can you see this clearly? You can say but 1, 3 diene or buta 1, 3 diene. All right. Now that's that. I'll do the last one, then you answer the other one for me. This one is a little simple because it's a straight chain. So all you have to do is to count the number of carbons. So here we'll be having 1, 2, 3, 4, 5, 6, 7. Let's number it to give it the lowest numbering. Though the way it is positioned, anyhow you number it, you still have the same position. All right. So this is 7. The double bonds are on carbon 2 and carbon 5. So 7 will be hepta. Hepta 1, sorry, hepta 2,5 diene, right? 2,5 diene, because the double bonds are carbon 2 and carbon 5. All right. At this point, if you have any question, drop it in the comment section. If you don't have any question, do this one, name this one, drop the name in the comment section. And if you've not subscribed to my channel, click on the subscribe button. Click on the subscribe button and subscribe. Like this video and share. Also comment the country you're watching from. Drop it in the comment section, so I'll share love from here. All right, see you in the next video. In the next video, we are teaching something very, very important. And if you've missed any video in this organic chemistry series, go back and watch them. It's in a playlist. See you in the next video. My name is Excellent Simplified.